Hi, everybody. Thank you so much for joining us for this Microsoft Reactor event today. We have our speaker, Mark, and I will pass it over to him in just a few minutes, but I do want to point out a few things. You should see an icon that is 2 text boxes, and the top text box has a question mark in it. That is going to be the live event Q&A. That is where you can ask questions. If they are topic related, Mark will be answering them during the presentation. If you have any questions about recording or other Reactor events, please feel free to ask those as well, and I will be answering those. In the live event Q&A, we will also be sharing some links. We have a few links to some Learn modules that we'll be talking more about. I'll also share a link to our Microsoft Reactor meetup pages and email sign up if you're interested in hearing about more events. And then also our YouTube channel, where this recording along with past recordings of our other events are all located as well. Thank you all again for joining us, and Mark, I will pass it over to you.
Awesome, thank you. So good morning or good afternoon, whatever time zone you happen to be in this morning. I'm Mark Gardner. I am a cloud solution architect with Microsoft, and the topic of today is we're going to be discussing building Terraform, so using Terraform in a 12-factor compliant way to build cloud infrastructure. And that's something of an interesting statement. There is going to be a live demo, and please, as Dion mentioned, please ask some questions, because I enjoy interactivity, so I would much rather answer some interesting questions than just burn through slides. First thing, we need to establish context of what it is that we're talking about. 12 factors, and depending, so what's really interesting here is depending upon what your background is, whether you come from like a software development background or more of a traditional like IT infrastructure management background, when you're looking at this slide, you're probably seeing 2 completely different things, depending upon that background. As we cover this topic, I want to make sure that we sort of baseline on the same things. So what are the 12 factors? That's the first place to start. So the 12 factors are a framework that describes how to build applications that can run on platforms. And sort of the genesis of the 12 factors were back about a decade ago. A company named Heroku launched one of the first application platforms into the cloud. They were one of the first in the market. And what they discovered was that a lot of their customers really struggled to figure out how to adapt their application architectures to successfully run on a managed platform. And so what they created was these guiding principles, this list of things that if you follow these principles or these practices when designing your application, it would be much easier and you would have greater success being able to run that application on a managed platform. And while that was specifically written, the 12 factors were specifically written for Heroku, they apply generally to any sort of application modern APaaS or application platform as a service. So that's the 12 factors. The 12 factors are this framework for building applications that run on platforms. And then Terraform. So Terraform is there's a couple variants of it. Specifically today, we're going to focus on the open source version, but the principles apply to the enterprise license version of Terraform just as well. But Terraform is a product by the company HashiCorp that is used to define infrastructure. It's an infrastructure as code. It's a domain-specific language for doing desired state configuration, and it's used for building cloud infrastructure on top of cloud platforms. It can also do other things like build within your data center or whatnot, but kind of the primary use case is for building cloud infrastructure on top of platforms. And so really, like, if we distill that down, Terraform is a tool that allows companies to build their platforms, their IT platforms on top of other platforms. So ultimately, like, these two things are sympathetic tools for building on top of a platform ecosystem. So we're not going to talk about, I'm not going to talk about all 12 factors. Really what we're going to focus on today is I want to focus on factor 5 specifically, and factor 5 within the 12 factors defines, it really kind of focuses on the principles of continuous integration and continuous delivery. And what it does is it describes that you need a strict separation between your build, release, and run phases within your application lifecycle. And what that's referring to is that's referring to that hard dividing line between CI, or continuous integration, and CD, or continuous delivery. And so if we break that down specifically, the build phase is described as it has a single responsibility. So in this case, build is synonymous with CI, or continuous integration. And the purpose of your continuous integration, or your CI, your build phase, is to produce a generic versioned artifact. Full stop. That's it. It ends there. Produce that artifact, and that's it. And one of the I'm really trying to underscore this, because one of the biggest mistakes that I see a lot of companies making is that a lot of times their CI process will sort of bleed over into their CD, and they'll do things where they start interacting with their environment in their CI phase. And you don't want to do that. Like, it's really important that our build is able to produce this generic, completely environment agnostic thing. And then the point is that you hand that generic artifact over into your CD phase, and your CD phase is responsible for orchestrating a series of deployments into different environments using that generic artifact. And as part of that release orchestration, what it does is it combines the generic artifact with the specific context of the environment as defined in that environment specific configuration, and injects that combination of things, the generic artifact and the environment specific configuration, into the environment to create the running context of the application within its environment. So really important, I just want to underscore it one last time. Your CI phase, it produces a generic versioned artifact, and your CD phase takes that generic artifact and combines it with configuration specific to the environment and deploys it into the environment. So okay, so that's an easy thing to understand within the application world, but it gets a little bit more interesting when we try to start applying sort of those same principles that we use for application development to our infrastructure. And that's really ultimately what infrastructure as code is about. Infrastructure as code is, this new paradigm that's evolved out of the cloud, the evolution of the cloud and the adoption of cloud platforms. All of our infrastructure now is virtual, and so we're going to start mapping these application patterns, these application development patterns, into how we manage our infrastructure as well. Because for the most part, we're interacting with our infrastructure through REST APIs or programmatic interfaces, and those activities look much more like software development than they do traditional IT infrastructure management. So how do we map what we just learned about the factor 5? How do we map that to this concept of infrastructure as code? So we're going to start getting into the specifics of Terraform from here, but so the most important thing that we can do is that as we're building our infrastructure as code, we have to make sure that we're writing our infrastructure as code in an environment agnostic fashion. So we talked about, the artifact produced out of our build needs to be environment agnostic. It can't have any environment awareness. And kind of the reasoning behind that is, and this is another common failure pattern that I see customers making, is when you're writing your infrastructure as code, it's very common for, well, I have slightly different requirements for what I want to run in production versus what I want to run in development. And like a common example of that is frequently a company will define they want to run so say you're doing a simple VM cluster of VMs, right? In production, you're going to run 3 VMs, but in development, you only want to run 1 because you don't really need 3 in development. And so what happens invariably is in the infrastructure as code, somebody will just write the statement, if environment equals production, create 3 VMs. And if environment equals development, then create only 1 VM. And the problem with baking that environment specificity into the infrastructure definition itself, into the code itself, is that you will never be able to exercise that production code until you get to production. So if there is an error in that production code, you won't find it until you're deploying it into your production environment. So a better way of handling that scenario is instead you can parameterize the number of VMs that you want to deploy. You just create a parameter that says number of VMs. You would expose that out of your infrastructure definition. And then when you go to do the deployment into dev, you would feed in a value of 1 because you only want 1 VM deployed. And then in production, you would feed in a value of 3. And the code that gets run is going to be the same regardless of which environment you're in. It's just going to change the number of VMs in which it deploys in that code. So in that scenario, that's an example of how we have a generic definition being combined with an environment-specific configuration value during the deployment phase. And the outcome is that because it's generic, we're exercising that same code in both our development environment when we deploy into dev as when we deploy into production. So we should have confidence that if it worked in dev, it will also work in production. So that's the environment agnostic aspect. The next one gets a little bit more complicated, and this is bundling of dependencies. So in the application world, this is a model that's existed for quite a while of, I don't want to have to continually reinvent the same thing. And so in software world, we have these concepts of dependencies or external libraries that we can reference within our code so that we don't have to write the same code over and over again. And so an example of that in like the infrastructure world would be, frequently I need to create database servers, right? I might create a single definition of what a database server looks like, store that and publish that as one artifact. And then in any place that I need to create a database server, I can just refer back to that one common definition and reference that and use that common definition. In the application world, dependencies are typically managed through things like npm packages or NuGet packages. In Terraform, there's this concept of modules in which you can create commonly reusable components of defined infrastructure to use. And then there's also this other concept that gets into sort of the details of how Terraform works. So Terraform itself has no direct awareness of any specific cloud provider. Instead, they have a plugin architecture in which they use providers, what they call providers, to do the translation from Terraform definition into the cloud-specific definition. For example, for Azure, there is an Azure RM provider that handles the translation of the HashiCorp configuration language, which is what you write your Terraform into the specific ARM or Azure Resource Manager language that gets consumed by the resource providers on the Azure side. These are also referenced as dependencies within your Terraform definition. So when you write Terraform, you declare which cloud providers or which providers you are consuming within your definition, and most specifically, you also refer to the specific versions that you are dependent upon within your definition. And this will be important, and I'll show you here in a bit an example of why this is important. But so this is another example of bundled of dependencies that infrastructure as code depends upon. So it's important that when you're building your artifact that you make sure that all of those things that your code is dependent upon, that the code that you wrote is dependent upon, that those things are also bundled as part of that artifact. So that you can guarantee that they are available when you actually need to go and run your code against your environment and create resources. So bundling of dependencies is very important. Versioning is another application construct that we're going to start applying to infrastructure as well. So as our applications change, because of that dependency chain of application code referring to other application code, we have this concept of versioning that allows us to kind of control how those changes are introduced into that dependency chain. A simple example of this, and one of the most popular, is the concept of semantic versioning. And I won't go too deep into the details here, but just to cover the basics, semantic versioning is a defined model for how you can version an application artifact. And basically, it gives you 3 digits, and each digit has a meaning. The least significant digit, or the rightmost digit, is your patch version. which basically means that whenever you increment that, you're making a minor patch to the application. It shouldn't really affect anybody who has any dependency on that code. The next digit up is the minor version. When you iterate that version, you're signaling that you have added features, but that the existing code itself is still binary compatible or should still work with anybody who has any dependencies. So just new feature, but everything else still works the same. And then the most significant digit, or the leftmost digit, represents a major change or a breaking change to the interface. Like when I release a new major version, anybody who's dependent upon my code is going to have to make changes to support that version. And this is applicable to infrastructure as well, because we're starting to, as we define our infrastructure as code, we're building a dependency between the infrastructure definition and the applications that are going to run on it. And so being able to tie those two together using versions that mean something. So the example would be that if you're versioning your infrastructure using a semantic model, your application can say something like, I am designed such that I will run on any version of this infrastructure between the major versions 1 and 2. And so then you can ensure that when you go to deploy that application, you have the appropriate version of infrastructure there to support that feature set of the application. And then the next one is immutability. The concept here is that once you've produced an artifact or a version of your code, your built artifact at the end of the CI phase, that thing should never change. It's versioned and it's defined and it's fixed. It's a fixed point in time at that point. So it's unchangeable. And the way that we typically enforce this in the application world is that our CI pipeline, at the end of producing the artifact, it will publish it into some sort of artifact repository along with its version information so that it can be consumed by other things that depend upon it. But the only thing that has access to write to that artifact repository is the CI process itself. Nobody can come in and inject other versions that didn't come through that pipeline or change the versions that are already there. So we want to make sure that we apply that same principle to our infrastructure as well. Once we've built and published a version of it, that version is immutable and it cannot change. Any changes must require that we must produce a new version. And then the last concept that we want to make sure gets applied to our infrastructure as code pipelines or processes is a concept of determinism. And effectively, determinism is this is a way of understanding the process in such a way that we have confidence that if we've run a change through our process 1,000 times and it's worked 1,000 times, then we should have confidence that when we introduce the 1,001st change, that it's going to work as well. And determinism is sort of this underlying principle that the process is well defined and works in an understood fashion such that it will reliably produce artifacts for us. And so we want that same thing for our infrastructure. Our infrastructure should not be it shouldn't happen willy-nilly. It should very much be on rails and follow a prescribed process, and we should have confidence in that process to produce reliable artifacts. All right, cool. So we've sort of described like the abstract of what we want our infrastructure as code artifacts to look like and what our CI process should look like. Now let's actually talk about how do we specifically implement that with Terraform. So Terraform has a handful of commands that map effectively to sort of our SDLC process or our software development lifecycle. So the first of these is Terraform Init. And what happens when you run an init, this is the first command that you're going to run within a Terraform workspace, is that this goes out and it looks at the definition, sort of the core definition that's been created within your Terraform code, and it's going to download any resource providers that you've referenced. So that scenario where I was talking about like the Azure RM provider and the specific version that I've referenced, it's going to go out and do the resolution for that provider, find it, pull it into my workspace. It's going to resolve any modules that I'm dependent upon. So those are those reusable code components that are out there. It's going to find those as well and pull those into my workspace. So this is, you can almost think about Terraform Init as being very, it does some other things as well, but one of its core features is that it's almost synonymous, like in the app world, with something like npm install or .NET restore. It's going to go out and pull in those external dependencies into the workspace. Then sort of the next thing that we can do is So let me step back real quick and sort of, I want to re-baseline on sort of one of the core responsibilities of the CI process, or the continuous integration process. So CI, its responsibility in the application world is to act as sort of that first filter, first quality filter for changes that are being introduced into an application. And what you really want is you want it to very quickly be able to give feedback on the change. So I, as a developer, I've submitted a change. I want really rapid, really short-term feedback telling me about the quality of the change that I submitted. Did I do, basically did I break the build? Did I introduce any bugs, right? And so we want that, we're trying to accomplish that same task with our infrastructure as well. And these are the tools that we do that. These are the tools that allow us to do that with Terraform specifically. So linting within the application world is this concept of doing syntactic validation of the code that we have written. And basically what that just means is is the code that I wrote, is that actually valid code? Did I follow all of the structures of the language itself? Terraform has this built in the Terraform validate command, which will lint the code for you and tell you whether or not the code that you've submitted is syntactically valid. So this acts as like a really quick check of just like, did somebody submit a good quality piece of work, or was somebody just like, throwing garbage at the CI process and hoping that it would make it through? So Terraform validates sort of our next check. This third one, this one gets really interesting. So in the application world, building the code is well defined. Like we all, at least from the application side of things, we all understand what building an application is, right? We're going to compile the code into some sort of binary artifact that can be executed. In infrastructure as code, the mapping of building an artifact gets a little bit looser, and part of the reason is that so infrastructure as code is meant to run on a cloud platform, and I can't exactly run that locally on my workstation. So I can't exactly build Azure in my developer workspace, right? Or I can't build AWS in my workspace. So I really need the context of those cloud platforms to be able to build the infrastructure and do sort of that first iteration validation of the changes that I'm submitting. So kind of if we loosen up our definition of build just a little bit and think back to sort of that context of this is meant to be a quality filter or a validation of the quality of the work that we've submitted, then the way we can start to think about this in terms of Terraform is what we're really trying to do. So previously with the Terraform validate, we did syntactical validation of the code. What we really want to do in the build phase is we want to do semantic validation of the code. And the difference there being that we want to, so before we validated that the code itself is valid, that it, we didn't misplace a comma or put a closed brace in the wrong place, right? Now what we want to do is we want to validate whether or not that code can actually be consumed by the target cloud provider that we're trying to run it on, and whether it can actually turn that code into resources running on that platform. And so if we think about it sort of that way, then what we can do in Terraform is we can basically just generate an empty plan against our target platform of choice. And the way that we do that is Terraform has this concept of workspaces. And really quickly, a workspace is basically just a logical grouping around a set of defined resources. So I can take the same definition and I can run it in multiple workspaces and manage multiple sets of infrastructure, but they're all tied back to the same code, the same definition. And so what we can do in our build phase with Terraform is we create just an empty blank workspace. We run our Terraform plan, and what that does is that will validate for us whether or not this code can actually run against the cloud provider, and it will spit out an artifact for us, which is the plan, which is one of the key concepts of Terraform itself. And then we don't really need that workspace because we're not actually going to apply this plan. And this is kind of the key point. The plan that we generate here is literally just a validation of, does it build? Does this work? So the plan gets spit out, and then but we're not going to run that plan. And I'm going to talk a little bit more about why here in a minute when we get into the CD phase of things. So we generate that plan, and that's our build validation of the code. Okay, so we have a plan. The next thing is, and this is a really interesting and kind of groundbreaking concept, is what else can we do with this sort of empty plan that we produce? In the application world, one of the things that we do after we build the application is that we validate any assumptions that we may have made when we were designing the application through a concept of unit testing. And unit testing is basically this idea that, like, if I take a set of known inputs and I run that through my application, because I know how the code works, I should also be able to define what the outputs are going to be. And so what that gives us is basically just a way to validate that the code is working the way we expect. Give it a known input, it should spit out, give it A and it should spit out B. So let's make sure that it does that. And that's what a unit test is. And we can do that same thing here with Terraform. So invariably, because we're describing our infrastructure as code, we're going to make some assumptions, and we're going, there are going to be programmatic constructs within our Terraform definition. And we want to validate any assumptions that we made when we were writing that. And we can do that here. So starting with Terraform version .12 and all the way up now through .13, they introduced a command called Terraform show. Stepping back just really quickly, so the Terraform plan that gets generated in the previous step is actually a binary artifact. It's only consumable by Terraform itself, and it's typically meant to be used in the Terraform apply phase to go and actually do the work. So the idea is that Terraform spits out this plan and tells you, here are all the changes that I'm going to make to your infrastructure. When you're ready, run the apply command and I will do that work. Starting with the Terraform show command, what we can then do is we can take that binary plan and we can actually convert it into something that's machine readable. And in this case, we're going to convert it into JSON. And once we've done that, once we've converted our plan into a machine readable format, we can use any standard application unit testing framework that we want to run unit tests against that plan. So we have a plan, we generated that plan, which told us, all of our code worked, and here's all the changes that here's the thing that we're expecting it to build based on our code. We can now use that to run unit tests and validate, does what it says it's going to do, does that map to what I expect it to do, given a set of controlled and known inputs. So that's a really advanced concept, and I'm sure some people are a little bit unsure. I'm going to show you a demo of us doing that. We are going to unit test some infrastructure here in a minute, and I think this is a very groundbreaking concept. So moving on. So we've done those first 4 steps. So at this point, we actually should have a pretty high confidence that our defined infrastructure is a good candidate to be released into our environments, right? Like, it's syntactically complete, it's semantically complete, all of our assumptions were validated. It should work. We should feel very comfortable that we're ready to go and deploy this thing into an environment. So what we do at this point is we create our artifact. And what our artifact is, because again, I said, it's not the plan that got generated. That build plan was simply a validation mechanism. It is not what we are going to deploy. What we're going to package up is we're going to package up the definition itself, and we're going to package up all of the dependencies that we downloaded in that Terraform Init phase. And then you might also package up your tests as well, because those might be valuable if you want to run integration testing as well. But the main idea is that we just zip up, the basic idea, zip up the directory. Everything that's in that directory, go ahead and zip it up. Things you might want to exclude would be like, if it's a Git repository, you might want to exclude the Git metadata. But in general, just grab everything in that directory, zip it up, version it, and publish that as your artifact. So we have an artifact. So now we're ready to deploy this thing. What do we do? So the first thing that we do is we're going to download that artifact into our workspace, and we're going to start the process of deploying it into our environment. And one really critical thing that we do not do in our deployment phase is we do not rerun the Terraform Init command. And the reason why we don't do that is because so in our build phase, we bundled our dependencies. If we re-init in our deployment phase, we potentially will change those dependencies. We potentially will pull in different versions of those dependencies into the workspace. And what that means is now that artifact that we're deploying is not immutable. It has just changed. So that means that, you know, my deployment becomes a temporal activity, or it changes based on when I did it. You know, I got one set of versions when I deployed last Tuesday. When I run it today, I get a different version of dependencies. So I'm going to get potentially different outcomes. So I don't have confidence in the determinism of the process anymore. So really important, we do not re-init. We use the dependencies that were included in the bundled artifact itself. Another, and this is just a specific to if you're using zip as your packaging mechanism. So zip itself drops all of the file mode attributes when it zips up files from a Unix system. Oh, and my demo just went to sleep. That's okay. We'll wake that up in a second. So zip will drop all the file attributes. So you need to make sure when you unzip it into your deployment workspace that you go back and you set the executable attribute on the downloaded providers within the .terraform workspace. And again, I'll show you a specific example of this, and that is just specific to zip. If you're using something like tar or gzip, then those things that shouldn't be an issue. The next thing is, and I talked about this previously, the concept of workspaces. So Terraform has built-in logical grouping of resources. Ultimately, these all get tracked against the same state or the same definition of code. So this is a really good mechanism to use to align to our environments. So the idea would be that we have one definition and we have many workspaces, and the workspaces, at least some of the workspaces, map to our environments. So that as we take that definition and we stamp it out in our different environments, we just change from one workspace to another workspace. That's not to say that you might not also have workspaces mapping to things like feature branches or topic branches within your repository, but it's really critical that you have workspaces that map to your environments. And then the next thing within our continuous delivery phase is that we want to make sure that this time span between the generation of the plan for a given environment and the application of that plan on the environment, that time window needs to be as short as possible. And the reason why is that plans are temporal artifacts. So in Terraform, when you generate a plan, it is looking at the current state of the infrastructure and comparing that against the definition that you have in code and determining a set of actions that it needs to take in order to make the infrastructure look like what you have defined. The longer that it takes you to go to apply that generated plan to the infrastructure, the more drift is going to happen in the actual running state of your environment, and the less valid that plan is going to be, and the more likely it's going to error or create some sort of failure. So you really want to keep that window as short as possible. And this is another one that I commonly see. I commonly see customers kind of validating this principle. And the reason being that one of the killer features of Terraform is the ability to generate that plan and have it tell you, here's what I'm going to do. And then you can like put human eyes on it, and you can feel comfortable that, you know, I'm okay hitting the OK button, letting this thing happen. And so a lot of times people will build in manual approvals into their deployment pipelines that say generate the plan and then wait for somebody to approve it before applying it. And that's okay. If that's something that you need to do to build confidence in your pipeline, that's fine. You can do that. The caveat that I would just say is that you really want to put some sort of like expiration and a fairly short one around that approval, because you don't want that thing sitting out there for long periods of time, because after some point in time, it's not going to work anymore. So you really want to try and control and keep that window as short as possible. And then the last thing about our continuous delivery for infrastructure is that integration testing goes into the delivery. It does not go in CI. In kind of this may seem obvious, but a lot of people will do this. They'll build infrastructure or integration testing into their CI, into their continuous integration. And the problem there is that in order to do integration testing, you need a running environment. And as we talked about at the very beginning, you don't create a running environment until your deployment phase, where you combine the artifact and the configuration. So if you want to do things like validate the running infrastructure after it's been created, you can absolutely do that, and you can use integration to do that. And that happens here in your continuous delivery phase. It does not happen in the CI phase. All right, I have done a lot of talking. I'm going to do a demo now, and to do that, I need to wake up my code space. And so while we're waiting on that to happen, I will happily answer one or maybe two questions. This should only take about 30 seconds or so. I don't know if there are any questions out there at the moment. I am pulling up. Okay. All right, I don't see any questions. I'm kind of surprised. Nobody really. I've not said anything controversial yet. All right, so quick context of what we're going to do. So I have a very simple Terraform definition here that all it does is it just creates like a basic VNet.
We just got one question if you want to take that one.
Sure.
It said, can this work on a hybrid CI/CD?
Yes. So what I am describing here are abstract generic principles. The tooling, the specific implementation of them is totally up to you. So at the end of this, I have a link to the resources if you want to go and pull this down and play with it yourself. You're absolutely free to do that. I've implemented Azure DevOps pipelines and GitHub Actions as my two CI and CD engines for doing this. There's absolutely no reason that you couldn't, do this with Jenkins or split those up and do different things as well. So that is absolutely possible. Again, these are just abstract concepts for how you should manage the process, and not necessarily a specific implementation on a specific platform. Cool. All right. So continuing down. So as I mentioned, we're going to create basically just a simple virtual network. It's composed of a couple subnets, and I've already pre-deployed this into. I have two environments here. They're modeled as two resource groups within Azure. So I have my test resource group. In it, we can see our test VNet, and at the moment, that test VNet contains exactly two subnets: my app subnet and my gateway subnet. If we come back here into my Terraform infrastructure, what we're looking at here, so I've done my parameterization. I've taken the address space of the VNet and I've parameterized this so that I can change this if I'm using different address spaces in different environments. I then have, so this is sort of when I was talking about those dependencies. This is where our dependency happens, or some of them do. So I've got my Terraform block here that's defining my minimum version of Terraform that I need in order to be able to run this infrastructure. I'm also managing my state store. So again, Terraform specific. If you guys are, if you're using Terraform, you really should be using some sort of remote state management, whether that's Terraform Enterprise, Azure Storage Containers, whatever. Just make sure that you really need that capability to do this at scale. And then here are our dependencies on the specific providers that we're using. So I'm using an Azure RM provider for this, and it's important to pay attention here because I've basically said that I want any version that is greater than or equal to 2.37 of the Azure RM provider. And that's going to be important in a second. And then down here, I just have basically my resource definitions, right? So I've got my resource group, I've got my VNet, and then I've got my two subnets, my gateway and my app subnet. So what we're going to do real quick is we're just going to kind of run through a simple scenario of like we want to add another resource to this. So I'm going to create a second subnet. We're going to call it app2 subnet. Oh, and then one other thing to point out here is within all of my subnets, I'm using this built-in function within Terraform for calculating my subnet range, the CIDR subnet range. And basically what this is just saying is given this existing address range, add another 7 mask bits to it, and then give me the first block out of it, and then the second block. And then for this one, we're going to take the third block, or not the third, 0 indexed for those who are paying attention at home. All right, so we've added our new change. So let's walk through our first example here. So we're going to init, which is what I'm talking about. It's going to go back. It's going to initialize the backend, which basically is connecting to that remote state store. And then it's going to start downloading my dependencies. And if we pay attention to what just happened, you can see, so remember, in my code up here, I said I wanted version 2.37, but what it downloaded was it downloaded version 2.38. And that's because what I really said is I said I would take any version greater than 2.37, and currently this is the newest version out there. So this is what I was talking about. Whenever you re-init, you potentially could get different versions of your dependencies. So you always want to make sure that you bundle your dependencies with your built artifact. All right, so we've initted. We want to do a validate, and we want to make sure that my code is syntactically complete, and it is. So it's telling me great, I'm valid. So then our next test is to go ahead and we're going to generate a plan. For I'm going to save it so that we can feed this thing forward. All right, so we're generating a plan. So what's happening now? Terraform is going out. It's taking the definition that I've created. It's comparing that against the defined infrastructure, and then it's going to give me a delta of the changes that it intends to make to that infrastructure. And so if we look at this, what we can see. So since I ran this, and it's also worth pointing out. So I mentioned the workspace concept. So I just ran this against my default workspace, which is my development workspace. You'll also see that there are test and production workspaces out there. So this thing is basically telling me, oh, hey, all right, I'm going to go out, I'm going to create a resource group, I'm going to create a VNet, and then I'm going to create a bunch of subnets. And we can see that it's going to create my app2 subnet in there as well. So I feel pretty good about this. I think this looks good, right? So I'm going to go ahead and I'm going to commit these changes, and I'm going to push them because I'm ready to see this thing get deployed. Oh, and so I mentioned that I have GitHub Actions and I have Azure DevOps pipelines. Those are in these directories. What we're going to be playing with today is we'll play with the GitHub Actions pipeline. So we're going to go and watch, once I do this commit, we're going to go watch this thing push. We're going to watch this thing push those changes out into my environment. So if I switch over here and we switch over into our Actions workflows, we can see that my change that I just submitted has kicked off a new workflow within GitHub Actions. And we can go ahead and we can start to watch what this thing is doing. So getting into the we can get into the details later if we like on the Actions workflow itself. But what this is going to do is it's going to run my CI phase, which is, remember, it's going to build and produce my artifact, which is just a bundled up version of the definition and all of its dependencies. And then it's going to publish that, and then it's going to kick off a deployment into test. Once the test deployment has happened successfully, it's going to roll over and also do a deployment into production. I suspect this is taking a minute because I am probably consuming all of my bandwidth at the moment by sharing my screen and running audio and video. So I'm going to spam the refresh button until something happens. Hopefully it wakes up. So while that's happening, while we're waiting on that, do we have any?
Yeah, we have another question that came through.
Sure.
It says, how does Terraform interact with Kubernetes and Flux? Can you differentiate between those and explain how they can be put together?
Yes. So Kubernetes. So Flux is really. So Flux is also a desired state configuration, or yes, it's a desired state configuration tool. It is really targeted, though, specifically at managing the insides of a Kubernetes cluster. Terraform is the next level up from that. So sort of the way that you would stitch these together, you would use Terraform to provision the infrastructure if you're using managed Kubernetes like AKS, you would provision those resources with Terraform, and then you would embed Flux into the cluster, and Flux itself would manage all of the pods, the stateful sets, the daemon sets, resources, definitions, persistent volumes, whatever, all your stuff that's actually inside the cluster itself. Terraform can do that, but that's really getting down. That's the next level down, which really isn't sort of its point. The point of Terraform is really to manage the cloud infrastructure, kind of that outer shell, and then Flux would manage the inside of the thing as well. This really should be finished. Let's we're gonna come back here. And all right, well, we may have to so what I'll do, we'll call on Audible, and we're going to go back and we're going to look at one of my previous runs from earlier, so we can sort of see what's happening. So if that ever completes, we'll go back and take a look at it as well. But what's happening within our GitHub Action pipeline is all the things that we described previously. So it's checking out the repository, it's configuring, installing, and setting up Terraform itself on the agent so that it can run the appropriate version of Terraform. It's initializing my workspace, doing exactly what I told it to do, and you can see right there it's doing that same thing where it's downloading version 2.38, despite the fact that we referenced we wanted 2.37. It's going to validate the code, so it's going to run a Terraform validate, give us a thumbs up. It's going to create a temporary workspace, specific to this build, and then it's going to switch into that workspace and generate a plan. And you can see sort of this plan happening here for the changes that it's going to work, that we want it to run. It's going to convert that plan into JSON. It's then going to run our unit tests against that plan. And we can see right here, it passed all 4 of my tests, which we need to go back because I didn't quite demonstrate that part yet. And then we published the directory. And as a quick cheat, this is that artifact that got published. So if we look at it, what we can see in here is we have our example.tf, which is my Terraform file itself. And then we have the .terraform folder, which contains the state file and all those downloaded dependencies that I talked about in the plugin directory. So this is our artifact that gets published at the end of this pipeline. And we'll take one quick peek back. Maybe I got lucky. Maybe this thing finished. It looks like it's just stuck in queue. So I guess not. We'll cancel this one and potentially run it again. I didn't talk about unit testing. So the other thing that's in this directory with this plan is we have just a standard XUnit. So I'm a .NET developer, so I picked .NET, but there's honestly any test framework that you want to use can do this. I did this with XUnit. So what we have here is we just have a simple test project. It reads the plan.json file out of the local workstation. It converts that into a dynamic set of resources, and then it runs 4 tests against those resource definitions for me. The first test is just a really simple one. It's telling me whether or not it's creating 4, how many resources does that plan say it's going to create. I expect it to create 4 because I defined 1 resource group, 1 VNet, and 2 subnets. So I expect there to be 4 resources. And then it does some other simple validations, like I want it to check and make sure it's getting deployed into the correct region that I defined, and then that it's calculating the subnet ranges to be, the CIDR ranges for our subnets to be the appropriate values I expect them to be, given the constrained inputs. So let's actually see this in practice. I was hoping to demonstrate this on GitHub Actions itself, but that doesn't seem to be in the cards today. So I mentioned that we can do this. So we're going to output the plan that we generated, which is plan.tf plan, and we're going to spit this thing out into a JSON file. And then what we're going to do is we're going to step down into our test folder, and we're just going to run a simple .NET test. And this is going to execute this test suite against that plan that I generated just a few minutes ago. And oh no, it failed. Why did it fail? Well, it's telling me right here, my first assertion was that I was expecting it to only create 4 resources, but instead that plan is creating 5. Because remember, I added another subnet. So I did the thing that a developer always does. I don't need to run the test. My code's perfect. And the unit test caught me and told me, oh, hey, wait, you validated the assumptions. You need to come back and fix this. So what we're going to do is we're going to just come in here and we're going to add another test to account for the new subnet that we added. And we're going to update this value right here to 5 to make sure that the new assumptions validate. And so we're just going to rerun our tests again. And hey, it succeeded this time. So we just unit tested our infrastructure. We just caught a mistake that it wasn't really a mistake, but you can see where the power of potentially I changed something and broke the CIDR calculations or something like that. And my test would have caught that for me, and I could have gone back and fixed the infrastructure code. So we're going to push new changes here. We're going to push those up, And we will see, hopefully we will get to see a running actual pipeline this time. And we'll give this just a second. Okay, there we go. This time it's actually going to run. So we can actually see this thing run through our full CI and CD pipeline. So you can see it going through those steps that we talked about previously in the CI phase, validating the code or initializing the repo, the Terraform workspace, validating the code, running the test plan, which is what it's doing right now. And then we'll see it go through and run all these other things. The thing that I want to show you is that once it completes running through the CI phase and we have our versioned and immutable artifact, it should start doing deployments into our two environments. And that should just take a few seconds more. So we're going to wait for that. And in the meantime, I'll look over here and see if we have any questions. It does not look like we do at the moment. So we will just wait patiently for our workflow to run through. So right now it's publishing up that directory, that artifact that I showed previously. Oh, and then kind of a last couple things is you always want to make sure that temporary workspace that we create for generating the plan, make sure that gets cleaned up. So that's what these two steps right here are doing, the switch back to default and then the delete the temporary workspace. And there we go. So you can see it finished doing our CI phase and it's rolled over into the CD phase and now it's deploying into our test environment. So we're going to let that go ahead and run. It'll deploy into test and then it'll also roll over and deploy into production. So I'm going to switch back really quick because I have one last slide. So a couple, I'll be super quick. TF state files, depending upon which resource provider that you use and the authentication mechanisms and other things, plan files and state files potentially may have secrets in them. Since those are getting bundled up in the artifact at your CI phase, you may need to be careful protecting those. Specifically with the Azure resource provider, if you use environment variables as opposed to hard coding your credentials for your service principal, there will be no secrets in your state file. So just kind of be aware of that one. I already mentioned use remote state store. Compliance releases. A popular thing, something that I have done with my teams in the past that have saved me innumerable midnight calls when on call is the concept of creating a compliance release. And what that is just create a scheduled release within your CD pipeline that runs your last known deployed version of your configuration against your production environment. I do it about 7:30 a.m. and Terraform has a specific command line switch, -- detailed exit codes. If you set that command switch when you run a plan, it will throw a non-zero exit code if it detects any difference between the actual environment and the defined definition. And so basically what happens is you get an alarm telling you, hey, your environment is different than your definition, something's wrong there. In almost always what that is somebody in operations went out, made a change to the infrastructure, and you just need to capture that change and make sure it gets reverse integrated back into your code definition. Rollback strategies, with this model, rollback is very easy. You just redeploy the last artifact in the case of a failed deployment. And then the last thing to consider is you can optimize this a little bit more by containerizing the pipeline and just shoving all of your tools into the container so that you don't have to pull them into the workspace. With that, I will double check if there are any other questions that I can answer because I am out of slides. And I'll pull, actually, sorry, last one. If you want the content from this presentation, you can go to this link. And then here's my contact details if anybody wants to reach out to me. We can come back here and see if this thing has actually deployed. Any questions?
We did have one other question. They said, any recommendations on how to do integration tests?
There are I have no specific guidance on that. There's a million blog posts out there. There's Terra Test is probably one of the most popular. There's Terraform Kitchen is another one that's really popular. There are tons out there for doing this. You can even do just like simple like PowerShell or Bash scripts that will validate the infrastructure. There's a bunch of different ways to skin that cat. Really, the core there is just whatever works for you, whatever validates your processes. Use those tools. I have no specific recommendation though. All right. And so we can see, I apologize. So I should also mention GitHub Actions. So I was trying to demo GitHub Actions as part of this. GitHub Actions is still a fairly new product, and it does have its quirks. I think we've run into that today where for some reason I can't, my jobs are getting stuck in queue and don't want to run. But I can assure you, you can see down here, there's multiple runs that did succeed. So, oh well. The demo gods were not kind today. All right, I am done if there's nothing else.
Perfect. I think just one last question. Someone had asked earlier that yes, please do share the repo. So would that be at that AKA link that you shared on the last slide?
Yep, I'll throw that slide back up for anybody who didn't catch it. Yeah, the content at that. So that link is a blog post that I originally wrote that covers this whole thing in greater detail, much greater verbosity, and there's links to the repository in there as well. If you're looking for the GitHub Actions thing content, the only caveat is that all of that is currently on the Actions branch within this repository. So go here and you will find it.
Wonderful. Thank you so much. And thank you everyone for joining us today. There are some links in the live event Q&A to a survey. If you have a few minutes, please fill that out. We would love to hear your feedback. There's also some links to some Learn modules where you can learn more about this topic, as well as ways to find out about our upcoming Reactor events. And yeah, and thank you, Mark, for this great presentation.
You're welcome. Thank you.
Have a great day, everyone.